bird. Gonna eat an apple or something, I guess. Looks like he's got a little horn out of the top, doesn't it? Yeah. It'll change in a while. We'll see something else. Okay, we'll start with problem 38. This is from section 1.4, problem number 38. There's nothing new that you need to learn to be able to do this problem. The question is, how disciplined can you be as a mathematician, and can you kind of have some foresight to see if something will cancel after you perform some operations? That's really the test. So what should you do first? Do you want to work with the left side or the right side? Yeah, the right side we would like to work with. As you can see in the top, we have y over 1. But in the bottom, we have x over y and y over x. We need to find common denominators, so multiply top and bottom by x. Top and bottom by y. And when I do that, I come up with a new expression. X minus. What's on top? Y, I'm going to write it as y over 1 divided by, what's on bottom? Good, x squared plus y squared over xy. So now, again, I'm trying to work with that complex fraction. The second step is to multiply by the reciprocal. So I'm going to take this piece, cross it off, and multiply by x squared plus y squared over, whoop, that's on the bottom. Multiply by xy over x squared plus y squared. Okay, if we do that, what does our new expression read? X over 1 minus what? Good. Now, we have two fractions. Is either one a complex fraction? Neither one's complex. Just have to find common denominators. What's going to be the common denominator? I take this part, multiply by x squared plus y squared. X squared plus y squared. Distribute my x. X to the third plus xy squared minus xy squared all over x squared plus y squared. You okay with that? Now it cancels. They're like terms, they subtract and go away. So your final answer will remain x to the third over x squared plus y squared. I like them apples. You guys ever seen the movie Good Will Hunting? You're not old enough yet. Well, some of you guys are. It's rated R. It's about a kid who's really good at math. He works as a janitor for MIT. He like solves the most difficult math problems, and they don't know who it is. Matt Damon's one of his earlier movies. Ben Affleck is in it as well. It was back when they were younger. They wrote the movie, I think. Can't tell you. They say an F word a lot, and it's not factor. That's why it's rated R. Function, yeah, what's up? All right. Let's try another one. 37, you guys said, right? 37. Mini driver is in it? You guys know what mini driver is? Robin Williams. You guys ever watched A Beautiful Mind? Now that's a good one. Okay. Complex fraction. What's the common denominator for the top? XY. So multiply top and bottom by X, top and bottom by Y. Common denominator for the bottom. So I'll write my new expression. What do we have in the top? Good. Well, that x squared minus y squared looks awfully similar to y squared minus x squared, doesn't it? In fact, they are identical except by a factor of -1. So we'll use that to our advantage. We can see the xy and the x squared y squared. Hopefully something should cancel there. We'll find out when we actually multiply by the reciprocal, which we'll take care of right now. So we write this as, see, I got minus, so x squared minus y squared over xy, and then I'll factor out that -1. So I have an x squared y squared. What do I get when I factor a -1 out of the bottom? X squared minus y squared, which is the same exact thing as the numerator over here. And since they're multiplied, I can then cancel them off. And now I have x squared y squared over -xy. Well, one of the x's and one of the y's will cancel. Leave you with the result of -xy. Beautiful. Sure. Xy divided by -1 is the same thing as -xy. I prefer -xy. What do you prefer? You don't know? All right. When you formulate an opinion, let me know. All right. Some people are really picky about their mathematics. It's okay. All right. You got that? So, like, you just bring your homework at night and show your parents, and they're like, wow, you must be really smart. You got, like, fractions over fractions. Like, as soon as your parents see a fraction, they call an accountant right away. They're like, I can't. Done. All right, cool. All right, well, hey, take out your notes. Let's move on. If you got other questions, come and see me. I'm not around tonight until 3:30. I have a meeting. I do not have a meeting tomorrow morning. I did have a meeting Monday night, Tuesday night, Wednesday night, Wednesday morning, Tuesday morning. But I'm going to leave my meetings behind for a while because my pre-calculus students need my attention. But again, how many credits do you get for this year of mathematics? 7. So you can expect that if you want 7 credits, it's going to require a little bit of work, right? So, you know, we're trying to put a lot in Too short amount of time. Equations. Let's go back to something that's easy for you, okay? Today's going to be pretty quick and easy for you. Tomorrow we'll get into more difficult topics about solving equations. Basically, the idea is this. When you see a general polynomial, you can look at the degree of the power of the variable and decide how many solutions it has. So what is the exponent on x here? 1. So therefore you have one solution. That's referred to as the fundamental theorem of algebra, which we'll get to later on. Extremely difficult to prove. Would take the better part of your lifetime to prove. But very simple to understand. We're going to have one solution here. So this is, kind of a more involved linear equation we need to solve. How do you solve this? What do you do? Distribute the negative 5. 2x minus 5x plus 5 equal 3x plus 2. So got to make sure you know how to handle your negatives. Combine like terms. I've got negative 3x plus 5 equals 3x plus 2. I'm going to gather my variables on my left side. Why? Because I want to. If you want to gather them on your right, go ahead. Be an individual. Negative 6x plus 5 equals 2. Subtract my 5. Negative 6x equals negative 3. So x is what? 1/2. Could I check that answer? How? Plug it in. Should always know what questions you got right around a math test, because most time you can check to see what your answers should be and what they are. Okay. And since we're in high school, we'll put boxes. Okay, so 3 over 2x minus 6 equals 21. This is different because it involves a fraction. No problem, we can deal with it. I'm going to add 6 to both sides. 3 over 2x is equal to 27. So a little reminder for you, how do you get rid of a fraction? Multiply by the reciprocal. So I'm going to multiply by 2/3. 2's and 3's cancel off, leaves me with x. I can take 27 times 2 divided by 3, or 27 divided by 3 times 2. Either way, it works out to 18. Strength. Plus. You're welcome. Woman. Yeah. All right, okay. All right. 4 over 3g plus 12 equals 2 over 5g. So now I've got fractions. Some people want to combine the fractions by finding common denominators. I've got a better way. Let's multiply through by a constant and get rid of the fractions altogether. You may ask yourself, well, why is that possible? Why can we do that? Well, watch this. Okay, don't do anything, but don't write this down. X plus 1 equals 3. What's the solution to that equation? 2. If I multiply through by a constant, is 2 still the answer? It is. So multiplying through by a constant does not change the solution to an equation. So what is the common denominator that I could multiply through by for C? 15. So I'm going to take this expression, multiply through by 15. I have to multiply everything through, both sides. So I have 15 times 4/3 g. You could divide or multiply right away, whichever one you want to. Let's divide first. 15 divided by 3 times 4. So I have 20g. 20 g's. Then I got 15 times 12. 180. And then I'm going to go 15 divided by 5 is times 2 is 6. So 6g. Now, isn't that a lot easier to deal with than the original problem? And if you're saying, well, no, I could deal with the original problem pretty quickly. Well, then just look at D. We could create situations where we could make it very difficult. So multiplying through by a constant can really change things for you. It's a good technique. So here I have 180 is equal to negative 14g. Divide by negative 14, and you get negative 90 over 7 is equal to g. What do you think of that? however you like to do it. You formulate your method of madness and stick to it. Okay, how about D? What do you multiply through by? Yep, negative 90 over 7. How about D? What do you multiply through by? 30. Let's start with the right side. What's 30 times 1/3? 10. You're so good, Preston. All right. 30 times 5x over 2. So I can take 30 divided by 2, which is 15, times 5x, which is 75x. We already said 30 times, well, Preston said 30 times 1/3 is 10. Let's go minus 10. And then let's be careful here. 30 divided by 5 is 6. Then we multiply that through on the top. 30 divided by 5 is 6, times 3x is 18, times 2 is 12. It's okay. Oh, yep. Does everybody see how I handled that? Okay, I'm going to combine like terms. 18x plus 2 equals 75x plus 10. So now it's a very basic three-step equation. Negative 57x is equal to 8. Divided by negative 57. X is negative 8/57ths. Done and done. Booyah. Question? Whoop. So I subtracted the 2 to get 8. I took the 12 and the minus 10 to get 2. Good question. All right. So in your first part of your assignment, you're going to be asked to practice solving these again, which is review for you guys. But, you know, you're going to have some where you can just straight up solve them and others where you're going to have to multiply through by a constant. And if you have questions, don't worry because some people have questions with these type of problems till they get a few practice shots at it, okay? All right, we move on to zero product property. We're going to do these 4 problems and then 2 on the back side, and that's our day, okay? Zero product property says this. If AB is equal to 0, then if A times B is equal to 0, then we know something is true. If A times B is equal to 0, then you know something is true. You know either A is 0, B is 0, or A and B are 0, right? Because 0 times anything is 0, okay? So we can use that to our advantage. If something is set equal to 0, we can write it as a product of parts and be able to solve it. So A is set equal to 0, but it's not written as products or factors. How does this factor? Good. This part right here represents my A. This part right here represents my B. So either A equals 0 or B equals 0. So you solve both of them. See, from the beginning, the exponent is 2, so I know there's 2 solutions. So x is negative 3 or positive 5. Those are my 2 solutions. How many solutions are there for letter B? There are 2 solutions. What makes B more difficult? Yeah, we have a number in front of x squared. So you can either use the guess and check method, or you can use the AC method. I'm going to use the guess and check method. I don't think 3 and 2 will work out. I'm going to try 6x and x. Think I should try 1 and 5 or 5 and 1? 5 and 1, you can see that 5x and 6x, those differ by 1. Which one's positive, which one's negative? Good, positive, negative. Take both, set them equal to 0, and solve. 6x plus 5 equals 0, and x minus 1 is equal to 0. What are your solutions? Good. 2 solutions. How many solutions are there for letter C? 3. What's the first step to factoring this? Take out an x. Does 4x squared minus 1 factor? Yes, it's the difference of 2 squares. Three solutions. Set each one equal to 0. X equals 0. 2x minus 1 equals 0. 2x plus 1 equals 0. What are your 3 solutions? Very good. 0 or 1/2 or negative 1/2. You don't have to write plus or minus 1/2. You can just write negative 1/2, positive 1/2, either way. How many solutions for D? 3. Set it equal to 0 to start off with. What method do you have to use to solve this one? Grouping. If you didn't have grouping, you would have to use what we call the rational roots theorem. We cover the rational roots theorem in chapter 3, not now, so you won't have to use it for this test. Okay? Can I put a parenthesis down in front of a negative? No, so I make it plus minus. Now I can put my parentheses down. What do you factor out of the first? I get x minus 2. What can you factor out of the second? Negative 1, x minus 2. What can you now factor out of both? X minus 2. Leaves me with x squared minus 1. How's x squared minus 1 factor? Solutions are plus or minus 1 and 2. Piece of cake, right? Okay. You do realize, though, how long it took you to learn that initially, right? So, I mean, it's like we covered, 3 months of material in, yeah. So, went by pretty quick. Let's go to something that's a little bit more complicated. We're going to stop after these 2 problems. But do you remember completing the square? CTS. So it's extremely important that you complete the square because later on you're going to be asked to know how to graph. We're going to have to graph circles, ellipses, parabolas, hyperbolas. And in order to do that, actually the form of a hyperbola is x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. And you're going to have to put things in that form and then be able to graph it. So again, you can see I know where we're headed and I know what we're going to have to accomplish. You'll be very good at that. You'll do it very well. But you see that there's 2 completed squares. So we have to be good at completing the square. You're going to learn one method for completing the square right now, which is what you learned last year from Miss Nelson. She did a very good job preparing you. Then I will teach you later on a separate method that happens when you don't have a 0 here. And we'll work with that later on. So, what's the first step you remember to completing the square? Good. What we want to do is we know this is true. A squared plus 2ab plus b squared is equal to the quantity a plus b squared. So you need a perfect square in the front, a perfect square in the back, and the middle has to be double those two multiplied together. Well, 5 was not a perfect square, was it? So we move it over. And we want to find one that is a perfect square. And the way that I do that, if you look at the formula, I will take my b value, divide it by 2 to get rid of that 2, and then square it to get this thing right here. So I look at that middle value, 2, divide it by 2, and you get 1. Square it, 1. So 1 is the number you add to create a perfect square. If I add it to the left side, I add to the right side. Now, since we've completed the square, we have a perfect square on the left-hand side. What is x squared minus 2x plus 1 factor to? X minus 1 times x minus 1, which is x minus 1 quantity squared. Is everybody okay with the step I've taken so far? Is there any question where I've come from? Bryn, Sid? No? Now, from the beginning, how many solutions do I know there is? 2. So, what do I do to both sides now? Square root. And when I square root them, the way I come up with my 2 solutions is I write a positive and a negative square root of 6. That will allow me to come up with 2 solutions. Now I finally solve for x. What do you do to both sides to solve for x? Add 1. X is positive 1 plus or minus the square root of 6. So 1 plus the square root of 6 and 1 minus the square root of 6. Those are my 2 solutions. We solve by completing the square. If you didn't complete the square, what would be your other option to solve for it? Quadratic formula. So we'll introduce that later on. Not today. Last problem, b. What makes b more difficult? There's a number in front. How do we get rid of it? Divide it off. When you see a number in front, divide everything through by that number. I get positive x squared, positive x minus 1/2 equals 0. What is my second step? Add the 1/2 over. Create my space to plug in the perfect square. Take the middle number. What's the number right here? Divide by 2? 1/2. Squared? 1/4. This factors to x plus 1/2 quantity squared. What's a half plus a fourth? 3/4. What to do to both sides? Square root. X plus 1/2 is equal to plus or minus. Good. You can take the square root of the bottom, but you can't take the square root of the top because it's not a perfect square. No, that's good. It's good. You try the problem ahead of time, right? And just a couple small mistakes. I mean, that's how you learn. That was me last summer doing the same thing. Now I subtract the 1/2 off. X is a negative 1 plus or minus square root of 3 over 2. So because they both have the same denominator, I can write them both as over 2. And that's the final answer. A plus? So, your assignment is really a nice set of problems that are review. We're not done with 1.5. We need to take a few days to get through. It takes a while. We just covered, these methods of solving equations. So the first set is linear. The next 4 problems are factoring. The last 3 problems are completing the square. Please make sure that you give some of those attention, and we'll be good to go. You guys are out of here at 1:14, so you're going to have about 5-6 minutes. So I'll be able to come around and answer some questions if people have it. We have 1 here, 2, 3, and back. Same question. Very good.